So our next speaker is Professor Ramesh. He'll be speaking to us on examining the relevance of Indian logical traditions and present-day AI developments. Professor Ramesh, please, you can speak to us. Once again, I want to remind us that the speaker's abstract and short bios is posted on the chat box. Please, you can check when necessary. Thank you.
I hope you can hear me now.
Yes, we can hear you.
Okay, I'm also going to try and bring my video if possible. Let me see. I'm going to stop the share for a second and then start my video. All right. And then share it again. Okay, can you see my video?
Yes, we can.
Okay, so this talk is actually a continuation. I'm glad for the previous presenters, Vaishak, as well as Professor Uduma, because actually you can see that this is a continuation of their talks. Um, and here I'm talking about the examining the relevance of Indian logical traditions and present day AI developments. Um, I'm a professor at Quinnipiac University in Connecticut. I'm also a fellow in at the Yale Law School, where I do work on history of computing, as well as on cybersecurity, privacy, and public policy. Um, and for a while now, I have been focusing on history of technology, and more recently on history of AI, which led me to kind of think about the history of technology in India, especially the history of logic in India. So that's what I thought I'll talk about here, and that's what I've been working on. So, and this was actually something that uh, presented itself to me when I read an article in 2018 by a person called Varun Agarwal, which is published at MIT Technology Review, where his uh, title itself is the in India's mess of complexity is what AI needs, and the subtitle was India's diversity of scripts, dialects, dress, and culture is a challenge that will make AI more resilient. So I kind of got to thinking about it and saying, well, so there is, it looks like there is some kind of a role that India and India's cultural context can play in the role of AI developments. And that's what led me to kind of look more into the history of logic in particular, even though I'm in general more interested in the history of computing. So where are we now with regards to AI? Well, we have a whole bunch of AI applications. They are the whole rage. At the moment, we have machine language, predictive analytics, natural language processing, facial recognition, of course, not to mention generative AI. Uh, and of course, we have newer algorithms, newer models. One of the newer models that we saw just now was the neurosymbolic model that Professor Vaishak presented. And then comes the issue of, well, so what's missing? The study of the logical foundations of AI um, is not something that we talk about a whole lot, okay? And the history of AI is also something that we don't talk about. Actually, one can argue that we are in what is called the third summer of AI. The first summer happened in the 60s when people came up with some basic formulations of AI. And that also led to all these chess playing computers and all of that. And that kind of died. Then came the second, so that was the first winter of AI. Then came the second summer where people developed expert systems like ELIZA and all of that, which could answer medical questions. And and I suppose I belong to that because my own doctoral dissertation was on expert systems. Um, and I was a doctoral student at Bell Labs in the US. And of course, that was also the time when neural networks were just beginning to appear. And I'm talking about the 80s, even though neural networks was conceptualized in the 70s. In the 80s, we had some basic neural networks, but they did not succeed because we didn't have a whole bunch of processing power and capabilities. But now, of course, we have processing power, and that is not an issue anymore. And we have come up with newer models and the transformer model and all of that. And as a result of which we have generative AI, which is flourishing tremendously. But I thought that it'll be nice to kind of delve a little bit into the, you know, logical foundations of AI so that students as well as educators will benefit uh, a little bit from knowing these logical foundations. Often, you know, none of these developments kind of came up all of a sudden. Um, Nor has there been any kind of quantum leap. We progress step by step in an evolutionary process, and therefore it's always useful to know a little bit about the history. And being a researcher in the history of technology, I thought that this would be interesting for me. So if you look at the logical foundations that are currently taught in schools of logic by and large, as well as some computer science departments which focus on AI, by and large we look at Greek logic, just as Professor Uduma explained in the last presentation. We talk about Aristotle, we talk about Plato, Diodorus, Philo, and we typically focus on the first order predicate calculus, syllogism. And of course, even though there are, dialectics and skeptics and stoics, all of these things, these are the ones that we talk about. Now, the question is, at least for me, well, so are there any other logical foundations at all? Now, of course, we know now that there is a Izumuzu logic, and there are several other logics too. So, for instance, Indian logic, because that's what I was interested in. And so I started looking at the Indian logical foundations, and I found out that right from 600 BC to 150 Christian era, that's the period when uh, Buddhist scholar Akshapada Gautama actually developed what is called the Nyaya Sutras, which is a very detailed conceptualization of what is considered to be Indian logic. And here's where we kind of start looking at various things. For instance, the colonials came to India in the 1700s, you can say, UK, or 1600s. And in general, the assumption that the West and the West alone has developed a science of reason was a fundamental axiom by these colonialists in the justification of the colonial enterprise as a civilizational process. In fact, this is actually a direct quote from Jonathan Ganeri, who is a philosopher from Oxford, as well as he's right now at the University of Toronto. And he's done a lot of work on Indian logic and Indian language constructs. And uh, essentially, when a colonial or a colonist comes to another continent or another country, the first thing they kind of look at is, well, um, how can I negate whatever is already there in that particular country or in that continent so that I can assert my superiority of culture and thereby bring the whole civilizational process. And this is my real justification for being a colonialist. So this was primarily what is called the colonial project, and this is something that has pervaded the Indian context too. Except that when they first came to India, what happened was they said, well, okay, in order to assert our superiority, what do? We kind of go and look at what's out there in the country that we have colonized. Okay. So they suddenly realized, oh my God, it looks like there is something called Indian logic in the Vedic literature. There's something called Hindu logic, okay, or Hindu syllogism. And then they started kind of writing about it in the 1800s, saying, well, I've discovered um, Hindu syllogism. And they talk about Nyaya Sutras and all of that, even though they've existed for a long time. Now, having discovered this, what they did was they started looking at more, in depth at Indian logic, and found that there was even a form of Indian syllogism, and that kind of led them to think that, well, okay, so maybe there was some development there in India too at the time of the development of logic in Greece. And the Indian form of syllogism, kind of the one that's quoted most often, is like this: this hill is fiery, for it smokes. What smokes is fiery as a culinary hearth. Accordingly, the hill is smoking and therefore it's fiery. So they looked at this and said, well, okay, so their immediate reactions, well, there were three reactions. The first reaction is, this whole thing is clumsy. Okay, it is not typical Greek syllogism. And why is that? Because the conclusion, that is, the hill is on fire, should follow just from two premises. That is, the hill is smoky, which is the minor premise, and where there is smoke, there is fire, which is a major premise. So you can just use the first three or the last three pairs for the syllogism. Okay, you can use the first three or the last three. Um, so what that means is that two parts were superfluous, redundant, and therefore Indian syllogism is underdeveloped, and they were quite happy to report that Indian syllogism was underdeveloped, and therefore the Western syllogism was superior or more well thought out. That was reaction number one. There was a reaction number two. Reaction number two was people who said, well, I'm going to be kinder to the Indian logic and the Indian logicians and make it look like Grecian logic. So there were people like the German historian Barthold Neuber, and he said, well, there are a lot of similarities, including Augustus de Morgan, and they kind of, in order to kind of prove the similarities, they said, well, I'm going to go to some Buddhist text, 500 BCE. So this is, prior to actually even Aristotle. And they said, well, so there is syllogism there, and therefore we can say that the Grecian or Aristotelian syllogism and Indian syllogism were autochthonous, meaning that they developed independently at around the same time. And Vidya Bhushana, one of the great scholars of Indian logic, more recently has talked and given the example of how these Germans and British mathematicians kind of tried to make Indian logic look more like Grecian logic. And they kind of went to this particular uh, statement or verse by that is available in this Buddhist text, Digha Nikaya. Okay. And what did they do? Well, they said, well, okay, this is how they kind of used it. My being wrong is a hindrance to me. The sense of remorse is due to my being wrong. The sense of remorse is a hindrance to me. They used, uh, Buddhist in texts and statements such as these in order to kind of say that there was syllogism, and therefore this was the autochthonous development of ideas, and thereby, there was something that was going on. Then there is the third, but then, and they also kind of tried to interpret it in the Grecian form. Okay, how do you do that in the Grecian form? Well, because they say, well, there is something there, but it's not perfect, so I'm going to interpret it using the Grecian form, whereby it'll kind of fit into the Grecian form. How is that? Well, so you have A, which is the mountain, and there is a fact or a characteristic of A, which is there's fire on the mountain, which is the thesis. And of course, the reason, and that's what we want to prove, obviously, that there is fire in the moment, and the reason for that in the mountain, and the reason for that was that, well, there is smoke in the mountain, and because we can say that gx follows fx, okay, and x being any for every locus of x, meaning that x can be any object, then GA then therefore determines FA, and therefore FA is fine, which means that there is fire in the mountain. So this is a kind of, I don't know, they were tying themselves into knots, trying to kind of somehow make Indian logic fit into the Grecian way of thinking about logic. So it seemed kind of an interesting way of doing this. And then, of course, there is reaction number three. And reaction number three says, well, do not look for syllogism in Indian logic. Instead, portray Indian logic as some other. We don't know what the other is, but the other, it could be something philosophical, something transcendental, whatever it is. One looks outward and is concerned about logic with the propositions of scientific logic. On the other hand, you look inward into the deep, dazzling darkness of mystical consciousness. I mean, they found India to be deep, and there was a dazzling darkness about it, and kind of put it compartmentalize and say, well, it is all mystical. We don't really understand it, but there is probably something there, and that is Indian philosophy. Okay, so that was basically what they were saying is Indian philosophy was important, but we cannot really compare that with Western systems of thought or logic, okay, which were more scientific in nature. So summarizing these reactions, what we see is that, you know, in general, what you see is that they attribute these Western colonists attributed the more importance to Western logical systems and seek to other the developments of logic in the East, and thereby kind of assert the hierarchical superiority of deductive reasoning through Aristotle style syllogisms. Okay, but there could be another interpretation too when we start looking at Indian logic, and that is more like rhetoric rather than formal logic. Okay, this exemplifies the debates between Hindu and Buddhist philosophers of the Nyaya period. For example, you can kind of use that same example where the hill that has fire in it is, well, you can have it as a form of argument. And how do you have that as a form of argument? Say, well, what's your thesis? Well, the thesis is that there is fire on the hill. Why? Because there is smoke there. So what? Well, where there is smoke, there is fire. Example, the kitchen. And the hill is such a smoky place, and therefore it has fire. So this is more like a rhetoric. This is more like a debate. It is more not like a syllogism in 3 steps. It has 5 steps. It follows rules, but it is more like rhetoric, right? So in fact, this is more inductive rather than deductive, which brings us to the emergence of logical relativism. And actually, for instance, Christian Greffenhagen, as well as Wes Sharrock in 2006, they came up with this idea of logical relativism, which is actually here in the last part. And what led them to say this was this stuff here, which is David Bloor, who is a sociologist, a British sociologist who went to Africa, to the Congo region and South Sudan, and suddenly realized that the Azande people, also known as Zande, have a certain type of logic. And in their logic, what they said was, well, witchcraft is inherited. Um, every man in their community was able to actually, uh, uh, transmit witchcraft to their sons, and every woman could transmit what is called witchcraft matter to their daughters. And by that particular logic, everybody in that particular village could practice or had knowledge of witchcraft, which they inherited, but which was certainly not true. And therefore, when David Bloor kind of went deeper and looked into this, he discovered that, well, actually, there were a lot of variations to the theme where they said, yes, while this is the general rule, sometimes in certain occasions it doesn't apply, and so on. So he came up with the kind of other explanations of this whole thing, which meant that, well, while there is a form of logic, that logic also has certain variations to the theme. Okay. And so our perception that knowledge of science, mathematics, and logic is somehow less susceptible to cultural conditioning itself turns out to be a culturally conditioned perception. That's what we kind of arrive at, right? In fact, there is the Mohist school, which is in the 5th century China, and they actually also have a logic which is based on informal analogical references. And then there is, of course, this is what led Christian Griffin Hagen and Shyrock to kind of propose this thing called logical relativism, where they talk about, of course, the alternative logic, which is a Zande Mohist. And also they say that there's some of the symmetric uh, properties of pure symbolic logic has problems because, you can kind of say, well, what if you say that anybody who deliberately kills people is a murderer? If that is considered to be a fact, then is a fighter, a bomber pilot who goes and bombs people, is he a murderer? Can he consider to be a murderer? At that point, symmetric logic fails. So they therefore came up with this logical relativism concept. Now, I would argue that Indian logic also is an alternative logic, similar to the logical relativism that they were talking about. And the emphasis is on inductive rather than deductive logic. It is therefore different from Aristotelian logic, but it should be treated as important in its own right. And in fact, professors like Matilal or philosophers like Matilal and Jonathan Ganeri have talked about it quite a bit. Okay, why? Because if you look at generative AI, the most recent form of AI, and I call this the third summer of AI, as I mentioned earlier, okay, it basically takes a given human content and instructions to complete the given task, and it uses generative AI algorithms. And there are two steps. One is to extract the intent information from human instructions and then generate content according to the extracted intent. Okay, so there are various types of generative AI models, diffusion models, variational autoencoders, generative adversarial networks, things that actually Professor Weishak explained earlier. And by combining several of these models, we can actually produce better human-like results. Okay. Now, how do you build these generational models, generative AI models? Well, you use foundation models. The transform model is one developed by Vaswani et al. At Google Research in 2016. And they use trillions of human-generated data. I also teach data science, where even a few years ago, we were teaching things like um, text analytics, where we would talk about coming up with 200 or 300 parameters and then creating using singular value decomposition to kind of put them in n-dimensional graphs or matrices. But now ChatGPT, the GPT-4, actually uses 1.7 trillion parameters. Okay, so billions and trillions of parameters are used, and they are trained and retrained because we have more processing power. So you can do all of these things. But how does it work actually? So you have a prompt, which is like a question like, what is a Titan? It is fed in, and then a model, which processes the equation, and then eventually, and the model is the one where you have all types of models. And this is where induction comes in, because you're looking at the context. And in fact, the transformer model paper that I alluded to that was written in 2016 talks about attention is all you need. Attention basically refers to context, and context basically then brings about arguments, and arguments are debates. And that's really, if you think about all that, as to how present day AI, generative AI, which uses all these things, a prompt, model, and a completion, you find that there is a lot of similarity between this and how you use the Indian forms of syllogism, the five-step syllogism. Okay, so the generative AI takeaways are, well, there's contextual reasoning, which is obviously something that you see in Indian logical traditions. And it is, of course, aligned with the recurrent neural networks and more generative AI models too. Okay, so summarizing, um, I think what I'm calling for is that there should be more pluralism in the histories of technology and also the history of logic. Okay. It says modern technology is based on universally acceptable principles. That's what Joseph Needham says. And of course, non-Western cultures, and this is Rajni Kothari, who's a sociologist, Indian sociologist, and she kind of proposes a post-colonial approach where she says non-Western cultures should develop pluralism as their approach to technology, drawing on knowledge and skills as well as Western, insight. Okay, so the conclusions are today's AI apps and models use inductive reasoning more than strict deductive reasoning. AI logical traditions are based on inductive reasoning, and it will be useful to study, therefore, these alternate logical traditions when developing new AI applications. And this is obviously very useful, not just for practitioners, but also students, and also how you teach the students when you talk about AI and new developments in AI, because history always provides a context and a foundation from which they can develop their knowledge. So that's how I would conclude this. Thank you very much to the organizers, to Amara and others. And I'd appreciate questions and comments. Thanks.
Thank you, Prof, for this insightful lecture. So the floor is open for questions, comments. Please, if you have any, kindly raise your hand up, then I'll call you to ask your question or make a comment. Both for Professor Duma's lecture and Professor Ramesh, she's a lecturer. Okay, while the audience are trying to, articulate their questions and comments, I have this question for you, Professor Ramesh. When Professor Jimai was presenting, she said something like that AI systems cannot reason deductively or in a symbolic, logical manner. So I'm very curious to know your thoughts on this. Thank you.
Can you repeat the question?
Okay, I said that, do you think that AI systems, whether the ones we have now or the ones that will be developed in the future, can reason logically in terms of deductive reasoning and symbolic reasoning?
Okay. Present present day AI systems are not built on symbolic logic. They are built on statistical models using n-dimensional matrices. And I told you about the representing these various tokens and their relationships in kind of what you may call n-dimensional space. And therefore, there's more statistics involved rather than symbolic logic, which was what I kind of, developed when I was doing my doctoral work. However, however, um, you know, if you go back to what Professor Weishak Bell said, so what they're trying to develop is a neuro-symbolic AI. Now, what I haven't read the paper. I joined in the middle of that particular talk, but what I could gather was that there is room for symbolic logic as well as the more neural network logic, okay, which is the more present day deep learning kind of approach, okay, to be joined together in order to produce a more superior or the next generation AI. So I think I obviously have to go and look at Professor Vaishak's paper, but I think that there are researchers who are already beginning to think about combining the two approaches.
Thank you, Prof, for your response. Please, if you have a question or a comment, kindly raise your hand up. We still have time. Okay, while we are still waiting, Professor Uduma, I have a question for you. During your presentation on African logic and AI, you mentioned the principle of complementarity, if I'm right. I am very curious to know how this principle will solve one of the problems we are currently facing in the discourse of AI, and even its practical aspects, is how to bridge the gap between human and AI relationship, especially in the field of medicine. So I'm very curious how this principle of complementarity that you talked about, that is very important in African logic, could solve this problem. Thank you. We can't hear you, Prof. Please
Your
unmute
question borders
yourself.
on how the concept of complementarity can resolve the issue of
Human to AI relationship.
yeah, the issue of complementarity. You have to talk about like when I explained it, you understand that complementarity is talking about what is lacking, trying to have a mutual relationship between it. And of course, when you look at the issue of complementarity, it has to do with reconciling what is here, what is not here with what is here. As a principle, complementarity has to do with bringing what is here and trying to reconcile what the difference, the gap, bridging the gap. That's what complementarity means. In any case, the major issue in AI gets back to the Turing's question, the Alan Turing, whether machines can behave as human beings. That is one area we talk about the issue of this thing, because we are saying that, and that goes back to the issue of consciousness. Because at the base of the question is the issue of consciousness. Are machines conscious? Can they take conscious actions? So reconciling the divide between the human being and the machines gets back to solving the issue of consciousness that Alan Turing posed. And go at from the 50s till now, we are still trying to see whether we can develop AI systems that will be conscious. But as to complementary, as to reconciling the gap between the human element and any principle that talks about complementarity can resolve any problem, because truth is no longer monolithic. You take what is here and what is here and bring it to. So that is what means complementarity, holistic. When I was saying that the logic is complementary and holistic, because I'm not talking about a logic of completion. It's not a logic of completion. So that completion involves bringing together and making sure that the elements that differ are brought into interplay. I don't know whether. Yeah.
Thank you very much, Prof. Please, do we have a question from the audience or a comment? Okay. In the absence of no question and comments, I think we'll be coming to the end of today's lecture and today's colloquium. I want to say thank you very much to our speakers for coming today to, share their expertise and their knowledge on both AI and logic with us today. Thank you so much. I also want to thank the people that joined us, that participated in this colloquium to make it a success. I want to say thank you. And thank you to the Conversational School of Philosophy for hosting this colloquium. And do have a nice morning, afternoon, and evening. Bye-bye.
Thank you. Bye-bye.
Bye.
Bye.